Some people coming in, so wait a couple of more seconds. Had a good lunch? Yeah? This is the hardest time of day to follow along with the session, right? This is not the most fun time to give a session, actually, because, yeah, that food has to digest and that sort of thing, so I know. All right, so let's get started. The topic for the next 50 minutes is going to be about security in mobile applications. So focusing, of course, on the Xamarin part. So I'm not going to do any iOS native stuff, or don't worry about that. So yeah, mobile security in mobile applications, quite of a hot topic lately. A lot of applications being built with Xamarin, but how do we secure those applications? And that's what I'll be focusing on during this talk. So my name is hasn't changed since this morning. I think it was a good idea to keep it the same as the session this morning. So I'm still Gill CLEEREN, coming from Belgium. If you have any questions, feel free to send me an email or contact me via the information that you see here on the slide. I also have Pluralsight, that hasn't changed either. So also quite a few courses that I have out there on Xamarin. I don't have a Pluralsight course on security in Xamarin. Might be a good one to do in the future. And also other stuff on .NET Core and that sort of thing. So if you want to find all my courses, that's the direct link that takes you to the page where all my courses are listed. There we go. And also I do on-site training, Xamarin on-site stuff, both at your company or wherever you want. I come and talk to you and teach you all about Xamarin that there is to know. All right, so enough about me. What are we going to be doing today? So how I've approached this presentation and this talk is actually around this thing called the OWASP Mobile Top 10. So I assume everyone is familiar with OWASP. So if not, I'll explain very briefly what it is. And they have this thing called the OWASP Mobile Top 10, which is a bulletin of 10 hot topics around security in mobile applications. So I'm going to explain those and see what the risks are that we have to try and tackle. I think my microphone is a bit too close to my mouth, actually, because I hear a lot of stomping in the sound. And so basically how I've approached this, we're going to look at the OWASP Mobile Top 10 first, and then we're going to do demos. I might have mixed things, but then I was afraid that I wouldn't go through the entire OWASP Top 10. So I've put all the demos at the end, and we'll see how many demos that we can do. So normally this talk takes about an hour 15, so I have to make sure that I don't talk too much, and that we can definitely take a look at the demos in the end. So that's what we're going to do. So before we start, maybe an interesting thing, an interesting question. Why do we need this talk, actually? Is security in mobile applications such a big problem? Well, the problem is, well, in the end, a lot of developers that build mobile applications, they rely on the platform. They think, well, Android and iOS, well, they keep things secure. And actually, as soon as we start looking at the OWASP Mobile Top 10, we'll see that that's definitely not the case. One of the biggest problems is, in fact, that the platform has a lot of things in place, but we don't always do things correctly. We may not test the applications enough. There might not be enough budget, or maybe not enough knowledge around security, or maybe just around mobile development in general. We have to release too fast. That's a problem that we don't only have with mobile applications. And a problem that you'll hear me refer to quite often is the fact that we'll have to start looking at what is a rooted device. Is this application actually running on a rooted device or not? And that can actually bring along with it quite a few other problems and risks in mobile applications. Anyone know what this movie is from? What this clip is from? Which one? Airplane, yeah. Such a great movie. It's for the old people already, right? Yeah. I'm near 40, so this is my type of movies. So, all right. So, as mentioned, we're going to do things along with OWASP. OWASP is, for the people who've never heard of it, as you most developers should actually have heard of it. So OWASP is a non-for-profit organization that actually they write a lot of texts and recommendations on how to build secure mobile secure software in general. So they focus, of course, mostly on the web, but they also do stuff around mobile. So it's a non-for-profit organization, mostly online. They have this ugly-looking website. It's horrible. It's like a wiki, a huge wiki where they have many documents and guidelines and that sort of thing on how we should actually build more secure software. And so they also do offline stuff. So they have like user groups and meetups and that sort of thing. And the most commonly used projects, they have a lot of projects, but the most commonly used ones is the OWASP Top 10, which is a web top 10 of most commonly encountered risks and how to solve them, of course, not only the risks. And they change it every now and then. And they also have this OWASP Mobile Top 10 that I already referred to, and that's the one that we are going to be looking at. So the OWASP Mobile Top 10 is like the word says it, it's a top 10 of most commonly encountered security risks in mobile application development. So they don't focus, they of course don't focus on Xamarin, definitely not, but they also don't focus on Android or iOS. They focus basically on, they make it a platform agnostic approach. They basically describe a risk, and sometimes they also describe how is this encountered in iOS, how is it encountered in Android. So that's how they approach things. So they don't focus on the technology, they rather stay away from it and stay on a higher level. We are currently at version 2, so the OWASP for web, that I think is current version 4 or 5. This one started at V1 in 2014. They've done an update in 2016, which hasn't changed all that much. The risks pretty much stayed the same. Some things were merged, some things had been moved in the top 10 a little bit, but basically a lot of things actually stayed the same. And so we're gonna talk about that. The good thing that I always like about, definitely about the mobile top 10, is that they don't only look at the application. They also look at it from a broader perspective. They also think about interaction with the backend, the infrastructure. So some of the risks don't really focus too much on the application, but they rather focus on, well, the environment where the application is running within. And that's, of course, a good thing. So here is the top 10. I'm not going to read it. Sorry, I'm not going to read that for you. You can read that yourself, but we're going actually to dive into each of these risks a bit further. I'm going to try to give you some information on where we can encounter this and where we probably are making mistakes against it. And as said, in the third part, we're then going to look at how we can solve the problems, because that's, of course, also an important thing. The first one is M1. So they're all numbered with this M in front, M for mobile, of course. The web also has that, but then it's numbered with an A, so it's not with a W. So the M risks, M1, means that's the first risk in the mobile top 10. And they talk about this improper platform usage. Now, for each of the risks that we'll encounter, for each of the problems that they describe, I've basically copied part of the text of the description of the definition, let's say, of that particular risk from the website. So I'm not going to read it all, but I'm going to give you a bit of an information on this. So the first one is called M1 improper platform usage. Now, this is this and M8 are, in my opinion, a bit high in the sky. It's not really that easy to grasp what they're talking about. Now, improper platform usage is a very broad term, saying that as a developer, we actually may be doing things wrong on mobile platforms. We can be thinking, wow, what a fantastic definition of a risk. I know that I may be doing things wrong. So basically, they say, well, Android and iOS, they have a lot of things in place that Apple and Google, they describe well in their documentation, but we know all that we don't always read the manual, right? So we may not be doing things 100% correctly. So that's what improper platform usage really means. We may not be doing things correctly. So it might be that, and they have this in the documentation, or in the definition, we may not be using Touch ID correctly, which is a security thing. We may not be using keychain correctly, or we may be setting way too many permissions in an Android application. So that's the typical things that this talks about. That's the definition, really. So I said this is a very broad term, and basically if you start thinking about this, well, basically they say every API call that we're doing into the platform, into Android and into iOS from our Xamarin applications, well, it can basically be an attack vector. And not only within the application, this is definitely one that thinks about the entire ecosystem in which the application is running. It might also be that we define an API in the backend, and you'll hear me refer to the backend APIs quite a few times for other risks. The backend API may also be set up incorrectly, opening it up for maybe an XSS attack or something. So that's also an important one. Asking for too many permissions, I've already mentioned that. That is also something that a lot of applications do. If I assume that you've installed applications, definitely on Android, where you install it and then you have to swipe through the list of permissions that you have to go through and that you have to approve for that application. Very often, that application asks for way too many things, and that's, of course, a developer doing things probably in ignorance, hopefully, incorrectly, or that might actually be that the application is doing things that is not documented and that might not actually be a kosher thing to do. So what are the risks here? Well, again, this is a very broad one. It might be that the application is storing data incorrectly on the device. And we'll talk about that in M2 because that goes in much detail on that one. But it might be that you are storing information on the device without securing that. That's improperly doing that, because it might not be good to store that information just plain on the device for everyone to read. You may forget about data loss prevention. For example, it might be that you're building a banking application, and typically banking applications should not be able to do copy-paste. It might not work. It should be prohibited to do that. So those are the things that we may do incorrectly. The operating system integrity, that's something that we'll talk about in much more detail later on, but it might be that your application is actually running on a rooted device. And you can actually detect that. And I've written an application where we were doing streams of video. And as soon as we detected that the application was actually running on a rooted device, we had to block all the streams, because probably there might be something listening. So rooted devices are a common problem, and you see them appear quite a few times as well. We may not doing everything correctly around SSL and securing the communication with the backend. Again, it's improperly doing everything that the device already describes. There's another one, privacy. There's also something that a lot of developers often don't think about. And again, the platform may have things in place for that, but we may not be doing it correctly. Blurring the screen. Think of what happens when you put an application in the background and it goes to the background. What the operating system does, it takes a screenshot, right? Your banking application might go to the background, and the operating system has already taken a screenshot of that. If that happens, that actually leaks information out of the application. So if someone takes hold of your device, you show me something, a video, or I don't know what, they can actually see your account information and that sort of thing. And actually that information too might get saved to the operating system's cache, which also could be read out by malware or something. So there's a lot of things that you don't think about initially, and that's what this M1 is talking about. We are not thinking, and we're not properly putting everything in place that the operating system offers. So I said this is a bit of a high in the sky one. The next ones are all much more applied into one specific area. Let's take a look at M2. Insecure data storage. Now, insecure data storage is pretty easy to understand, right? If you read this sentence here, it basically means that the developer has insecurely stored information on the device, and someone gets hold of the device, and yeah, it can read out the information that is on the device, which is something that quite often happens. Now, I was just doing a training very recently, and I was talking about this as well. And there was a guy in the audience that said, well, whom is ever going to have access to that device? What is the chance that the device actually gets lost? And so he said, I said, maybe the chance of the device getting lost is not all that high. So he said, I'm going to store everything in plain text. I don't really care. Well, I said, what happens if that device becomes rooted? A lot of Android applications run on rooted devices, meaning that people can install whatever they want from third-party stores, and that comes along with some malware that reads out everything that's unencrypted on the storage and sends that back to some place in the background, in the backend. So that actually happens. So it doesn't always mean that the device has to be physically stolen, but malware on the device can actually leak information to some malicious user via malicious code that is running on the device. So a lot of things that you may not think in the beginning actually could happen even without physically giving access to someone to the device. So that might impact a single user, might definitely impact a lot of users. If you're storing information, passwords to the backend in plain text on the device, I don't think it's a good thing. One thing that actually might be a bit of help, and again, I don't think this is a fully waterproof solution, is applying some MDM tool, so mobile device management, so that remotely you can still wipe a device. That actually might help a little bit. So basically, as soon as your application is storing information on the device, could be a log file, a SQLite database, an XML file that you've downloaded, JSON, everything that you store can actually be of a security risk. There's definitely a lot of places where this can appear. And again, and you'll see this happening quite a few times, these M1s, M2, and 3, they are going to be interconnected, right? Like I already mentioned in M1, it might be that the operating system takes a screenshot of your application, stores it on the device, and if you haven't secured that screenshot, if you haven't blurred everything out, well, it might be that the operating system is insecurely storing that screenshot, and malware can still access that. So that information is still accessible that way as well. And also think of frameworks that we use. We all use NuGet packages, right? Whom reads all the code that is actually inside of that NuGet package. I don't think there's a lot of companies doing that. There are companies actually doing that, and they don't allow the use of external NuGet packages, but a lot of companies just say, use whatever you want, and you don't know what those packages are doing. Maybe they're storing something incorrectly or insecurely. Here I have a screenshot. I'm not sure if it's really readable, but this was actually a SQLite database where the developer was a bit of an artist, and he actually saved the username password in plain text directly in that SQLite database. It is just as simple as connecting that Android device to your PC, reading out that SQLite database, and boom, you have access to the backend, and you know what you can do then. So basically, this is doing that incorrectly. SQLite databases is also a typical thing that we should actually secure. Now, does it have to be on the device? Of course, I think this is pretty obvious. There's a lot of things going on when communicating with the backend. So insecure communication, of course, pops to mind. And that's what M3 is talking about. Basically, as soon as a mobile device is talking with some backend in a client-server configuration, we are going to send information off of the device. And that information is susceptible to being be kept somewhere, to be intercepted somewhere. There's a lot of things that can go wrong along the wire between your application and the backend. There's a lot of things that actually can go wrong. So this happens as soon as information goes out of the device. And there's a lot of things that can actually go wrong, right? A lot of places, a lot of hops that the data is coming through, and a lot of places where things can go wrong. And when we do this, when we think about insecure communication, we definitely have to think of what do we really need to secure. Well, there's a couple of things that you have to think about. We really have to do three things. You have to make sure that the data that is going back and forth is integer, meaning that no one has tampered with it. We also must make sure that the data hasn't been intercepted, so that it actually wasn't read out by someone along the line. And we also have to make sure that the backend that we're talking with is actually the one that we're expecting to talk with. This comes back to a so-called man-in-the-middle attack, and I'll show you some things that we can do about that later on. But this is actually, it could be that your application is actually doing everything correctly, but it's rerouted because of something in the backend happening, and it's actually rerouted to an attacker that is intercepting all the traffic and makes your application think you're actually still talking with the original backend, but you in fact may not be doing that. And we can actually fix that. We're going to see something called certificate pinning, for example, which actually can solve this particular problem. Now, this can happen, as mentioned, in quite a few places. Go to the nearest Starbucks, whatever. A lot of people, they don't understand all the risks that come with free Wi-Fi. I typically put on some VPN as soon as I'm in just any Wi-Fi. Probably it's actually I'd switch it off now because otherwise my emulators don't work. But in most places, use a VPN because Wi-Fi's can be compromised. And a lot of people in the airport, in the Starbucks, they say, "Oh, free Wi-Fi, just connect with that." But it doesn't always it's not always the correct Wi-Fi. Just if I go to Starbucks, I share my Wi-Fi. Hey, this is free Starbucks Wi-Fi. Everyone will connect to it, and it's very easy to see what is going on over the wire. And if you then do not encrypt the traffic that is going over the wire, well, then it is just a piece of cake to intercept just username, passwords, tokens, whatever. Everything is going over the wire. Hence, a lot of applications can get hacked and backends can get hacked as well. It might actually happen on a level that is much more difficult to figure out. It might happen on a carrier, so on devices. It might actually be that a hotspot here in the conference area is also hacked, and there's malware on there that also can intercept traffic. So for those reasons, it is definitely not acceptable to let a mobile application talk with the backend over an unsecured way, basically. And we're going to see how we can do that in Xamarin, what is supported. What I also see happening quite a few times is that that developers, they say, well, we have secured the application. We have secured the actual authentication page, whatever, screen. Yeah? And after that, they start communicating again without authentication. Yeah? If you think what happens, you authenticate, you probably get back a token, and I'll show you how we can do that with an OAuth token. And we're going to see how we can do that to secure authentication. But after that, they switch the SSL, so the TLS communication, back off, and they start communicating back in plain text. Of course, that's pretty much useless to do it that way, because then the token or username, whatever you use, is going after that authentication call, is going again in plain text over the wire. Hence, you've done something, but you've done it incorrectly. And also some of the things that you see here happening, it doesn't always have to be Wi-Fi. It could even be Bluetooth, NFC, just any type of communication, any place where information is going out of the device. Well, basically there you are susceptible for this problem. We're going to see a couple of things to solve this. One of them is certificate pinning, where we basically check if we're talking with the correct backend. Of course, enabling TLS is also something that we'll look at by the end of the presentation. So we'll see how we can solve this particular problem in quite a few ways. All right. M4 is actually going a step further. We're doing authentication, but we're doing that in an insecure way. If you look at this one, again, this is a bit difficult. The explanation, let's say, is a bit more difficult. They say basically, once an attacker understand that they is the attacker, once they understand how your application is doing its authentication, well, then they will try to bypass the application and do the authentication maybe via some brute force attack with some tool without the actual application. So they basically will try to monitor the backend calls that your application is doing for its authentication, and then it will actually start doing those calls directly with the tool instead of going via the application. So this is actually more, again, like I said in the beginning, this is not only about you doing the communication in the application, but also in a broader term when you're doing the authentication with the backend. So the backend, of course, is an important thing here. You often see this happening, that developers think, well, you know what, in the mobile application, the user has limited input functionality. So let's make the authentication scheme that we use for the mobile application simpler than what we do for the website. And that's totally wrong. You see developers thinking, well, I'm not going to do two-factor authentication for the mobile application. Maybe it's too much work for myself as a developer, or maybe it takes too much time and that sort of thing. Then we have to bring in SMS codes and that sort of thing. Well, actually, there's been cases known where the website has been hacked, where the website was nicely secured, because the mobile application using the same authentication backend was actually using a simpler authentication scheme, because they didn't use two-factor and that sort of thing for the mobile application. So then the mobile application compromises the website. And that's what you're getting then. Another problem is that mobile applications can do authentication offline sometimes. I've seen cases where we actually store information locally, and an attacker can see that. They can definitely do reverse engineering on the code. And so basically what they do is they try to see what are you doing on the client side. Maybe we can use that to try to replay the attack, the authentication attempt, and does the attack on the backend. So there's a lot of things that actually can be done incorrect. This I've already mentioned, and that's the next one that I've already mentioned. You also see this happening. A lot of developers, and this happens in web, by the way, as well, very often. We see people saying, well, this is an API backend that you cannot get to as long as you haven't gotten through the login screen, right? So we let that API call wait there anonymously. That is definitely not a good thing. Don't do that. We have that in websites as well. There's a lot of admin pages that if you simply go to /admin that are available, because no one is checking that you're authenticated and that sort of thing. So anonymous APIs, you may be thinking, well, that's not going to happen to me. Well, it happened to a lot of other people. There is so many pages, APIs, which are open because of the developers thinking, well, you have to authenticate before you get there, so I'm not going to do that. Of course, that's going to be found. Don't expect security through obscurity being a good thing. It's not a good approach. Well, you see a lot of people actually think that is a good approach. This comes back also a bit to the insecure local storage thing. Yeah, some applications, the user has to log in with username and password, and the developer simply stores the username and password in plain text on the device. And then the developer says, yeah, who cares? No one knows. Well, actually, they do know. And like I said, malware can easily detect it and send that back to a backend. Something that OWASP also recommends is not using the same authentication token on the same device. So they basically say, well, you should actually, if you do two-step authentication, for example, with an SMS text message, you should actually do that on a separate way, a separate device. Well, that's not always an easy one. I find mobile applications should actually be able to do that. But there's cases known where, for example, the SMS code coming in, so the verification code coming in via an SMS was actually intercepted by malware and used to do the authentication that way. So that I find a bit far-fetched, really, but it has actually been proven that this can be used to attack applications. This I've already mentioned, I think. So the authentication should be at the same level. I've mentioned that. Also make sure that if you do offline validation, that doesn't pose a risk. If you follow the same authentication scheme, don't let that fall back on the fact that it has to have a username and password locally stored, because it actually might cause a lot of issues along the way. And if you do valid authentication, make sure that you do that as much as possible on the server and avoid doing that on the client side. Definitely don't store username and passwords insecurely. So that's I think it's a pretty logical one, right? A lot of things in this are pretty logical, but you have to think of it. And a lot of developers simply ignore all these things. And 5 talks about insufficient cryptography. A bit an out of band because the next one is back to authorization. Cryptography basically means if we do encryption, and some user actually gets hold of the device, or again malware actually gets access to the device. We are securing stuff, but we're doing it, or we're encrypting stuff, but we're not doing it with a correct encryption scheme. Might make sense to actually do it with a simple one, but actually it doesn't make sense because when you do encryption, do it correctly. What are we encrypting? Well, we should encrypt local data. That's a normal one, we've already mentioned that, but also network traffic. And this boils back down to using TLS, for example, to do your encryption as well here. So there's a lot of things that you can encrypt, going data in the wire and data going over the wire. Yeah? That's the typical things you need to do. You also see developers still using older authentication or encryption schemes. If you do encryption, do it with the correct one. There are a lot of encryption schemes which are outdated, which are flawed, which have been proven to be insecure. Don't use them anymore. Go for the newest ones and don't use the old ones still at this point, because if you use old encryption schemes, well, it's pretty much the same thing as not doing any encryption at all, because those schemes are actually flawed. Again, we fall back on the platform sometimes. Sometimes developers say, well, in iOS, for example, iOS is secure, more secure, let's say, than Android in many cases. In iOS, well, we can only run encrypted code. So why don't I put maybe an API key or something inside of the application? Nobody can access that because Apple guarantees that it cannot be accessed. Well, tough luck. It actually can be decrypted pretty easily. It's very easy to download an application from the App Store that can easily be decrypted, and therefore that information that you put inside of the application, the package, can also easily be decrypted. So that's not a good place to do the information as well. So don't rely on the platform for encryption. Do it yourself. You also see people sometimes doing encryption, but they're not very smart where they place the keys. They simply place them next to the encrypted data. That's putting the cheese with the mouse, or how do you say that in English? So it's not a good thing to put everything together. Don't put the encryption key right next to the encrypted data, because then everyone can decrypt information as easily. You also see people sometimes thinking, you know what? I'm not going to fall for the fact that some schemes are outdated. I'm going to create my own encryption scheme. Well, there's people working on those things for years. Don't think that you can do that in a better way. And of course, don't use the old ones. Things like MD5, they have been flawed. They've been known to be insecure for years. Well, don't rely on those to actually secure your information. Insecure authorization is M6. Is a bit of a mixed one. There's a lot of things that actually can go wrong in terms of authorization, really. What does it basically say? Well, it can have to do with the backend not checking if you have actually performed, let me put that differently. The backend is not checking if the calls that you're trying to make are authorized. It's a very simple one. It actually boils back to what I've already mentioned. If you're doing an API call and you're allowing access to that API call anonymously because the user has to log in first, well, this is pretty much the same. You're doing an API call, and the attacker may have found that API call in the code by reverse engineering it. If you do not check on your backend if the user actually has permission for that after being authenticated, well, then you're basically violating insecure authorization. That's what this thing is all about. You sometimes also see that hackers will try to brute force through the application or the backend, actually maybe through the backend, to see which endpoints are available. And if those are not checking that the user has been correctly authorized to access the information, well, then this one comes into play. What I also see sometimes happening is something called, which is an OWASP Web Top 10 thing. It's a threat called the Insecure Direct Object References. What is this thing all about? Well, you have an API call that, for example, gets the logged in user's information by passing in the user ID. So user ID equals 123, and you get back the profile info or something. And You can easily see what the API call is being made from a mobile application. Just plug it into your device and you can see what is happening using Fiddler or something. You can easily see the backend call. And if I change the 1, 2, 3 by 3, 4, 5, and I still get back information, well, then I'm violating insecure direct object references, which is a web OWASP top 10 threat. I basically can make a call by simply changing an ID, and I get information that I'm not supposed to see, which actually should be captured, which should be caught, let's say, by the insecure authorization validation that you have done. You check that you are authorized to see the information that you are requesting. What I also sometimes see happening is that a mobile application gets in a JSON object that specifies which roles I have in the mobile application. Maybe can access products, can order products true, can remove products false. But that's just a JSON information object coming into the application. That's pretty easy to fake, right? So if the hacker sees that and he changes that JSON that's coming into the application, then he can maybe get extra permissions inside of the application and hence perform stuff on the backend as well. So always do those validation for authorization also on the backend, because otherwise you're susceptible for this threat. Poor code quality is something that we don't have. We never have poor quality, right? Now, this is one that is a bit harder to detect, which is also why I don't really, I'm going to give you any examples of this, because this basically says, well, it might be that there is flaws, that there's holes in the operating system, really, that may cause buffer overruns or overflows to happen, hence allowing the attacker to run malicious code. So this is much more low level than your average thing that we've already seen, right? This is much more low level. The hacker already has to have a lot more knowledge to actually see this thing in action. So I'm not going to spend any time on this. It can happen, but this is the one that we are probably not going to be able to do a lot about. And made code tampering is also something that you see happening quite often. Code tampering really means that perhaps in a third-party store, the user is going to put a fake version of your application. Again, you may be thinking, well, what can I do about that? Well, in fact, you cannot do all that much about that one. So basically, it means that the developer, so the attacker downloads your application, maybe from the actual Google Play Store, and what they will do is they will reverse engineer the code, which is, by the way, M9, so I'm coming back to reverse engineering. So they might actually create a fake version of your application, put that in a third-party store, and try to trick the user into installing that version instead of the regular version. And that version, of course, has been tampered with. Maybe the form is submitting information to a fake backend, hence giving the hacker or the attacker access to the credentials that the user is using in the regular application. Like I said, there is not that many things that you can do about this, because once the application is on the device, it runs there and, well, it's out of your hands. So this has typically to do with rooted devices. It might be worth checking when you're running the actual application to check if the application device was rooted. But again, if the code has been tampered with, it's out of your hands, basically. So you're really not in a state that you can do all that much with. It happens mostly with games that promise like in-app purchases, which have already been done for you, so the freemium versions of those in-app purchases. If this happens with a banking application, well, yeah, then it's definitely a big problem. So this often happens in combination with social engineering, tricking people into installing a fake version of the app. Typically goes through Twitter links or Facebook links or phishing mails. Again, this is not something that we should be, that we can do all that much about. It's something to be wary about, and maybe there's actually companies that specialize in detecting these third-party apps in stores and try to remove them. There's actually companies that do nothing but just trying to remove fake versions of applications. M9 talks about reverse engineering, which is very closely related to code tampering. So reverse engineering basically comes down to, well, an attacker downloads an application from the store and reverse engineers it. With the Xamarin application, I think it's like 2 seconds of work. There's Chrome plugins that allow you to download the APK from the Android Google Play Store to your device. An APK is just a zip file, so you can rename it into zip. And if that's a Xamarin application, you can see the DLL sitting in there. So that is simply a couple of seconds of work. You use .peek or just decompile. Just any .NET decompiler will decompile Xamarin applications for you. Now don't think, this is a Xamarin problem. No, this happens in pretty much the same way with native Android applications. It's a bit more complex, like I already said, with iOS applications, so native iOS applications, but with Xamarin applications, you're basically all the information is up for grabs. Now, that can, of course, bring along with it enough problems around IP, intellectual property. Yeah. What about resources and the layout that you have created? Well, Xamarin applications have that information in there, so anyone can access it. It's probably a bigger problem if you start putting secrets in the code. Like I said, that's never a good idea. But things like API keys, putting those inside of the application might actually be a bigger problem. It might actually, like the API keys, it might actually result in attacks on the backend happening. So I've mentioned this already. So it's just a zip file. We can decompile it. If you look at solutions, look at obfuscation. Obfuscation won't help you 100%. It might help you a little bit, but it won't help you 100%. It's definitely not waterproof. Often when I talk to people about security is basically try to put layers of security on top of each other. Obfuscation can definitely make the attacker move to the next application because your application might be a level too hard. It's pretty much the same as keeping people out of your application. Make it you're not going to be able to make it impossible, but you're going to make it harder, and that's going to back them off basically. And then number 10, and then we'll start looking at demos, is also a bit of a weirder one. It talks about extraneous information in your application or functionality in your application. Now, what is that all about? Well, that term basically points to your application or maybe your application code containing information that it shouldn't contain. Things like, I think we've all made the mistake of deploying an application, maybe a web application or what have you, with in there some maybe some constants that say, well, this is the QA environment, this is the test environment. Well, submit that. It only will use the production environment. But if that information is inside of the code, reverse engineering will actually be able to get that information out. Not if it's commented out, because then it's removed, but if it actually is inside of a code, and it's even not if it's not being used, it actually stays in the compiled application. Typically, hackers or attackers will also look at things like output. So maybe they plug a device into a PC, and then Android devices will typically show a lot of output. I've seen cases where that actually shows username passwords sometimes that are being opened and that sort of thing. Log files can also contain a lot of information. So that's where an attacker in this case will typically look at. So try to make sure that the code is clean. Let it contain unofficial endpoints, APIs, and make sure that all that gets removed. Often this results in a code review. Maybe even a manual code review. Static code analysis can help you a little bit, but not 100%. So there's a lot of places where you can actually make sure that this thing doesn't bite you in the end. All right? So that is basically what the mobile top 10 is talking about. And so for the rest of the talk, I'm actually going to try to help you in solving those problems, because there actually will be solutions for these. Not for all of them, as I've already mentioned, but we're going to see how we can solve them. All right. And again, I haven't put them in a certain order. So I have, I think, like 5 or 6 solutions that we can look at. So, sorry. I think in order of importance, things around authentication, secure communication probably should be looked at first. So that's why I have insecure authentication, actually a solution for insecure authentication, which is called Xamarin.Auth. Now, insecure authentication basically talked about the fact that we are doing authentication incorrectly. And it boils down to doing the authentication incorrectly, making it too easy to hack that, and also to store those credentials in an insecure way. So it's basically 2 steps that we have to look at. All right. So Xamarin.Auth is a separate SDK that comes with, that's actually made by Xamarin, so by Microsoft. That allows us to do exactly that. It allows us to do authentication in a secure way, and also allows us to store information in a secure way, using an abstraction on top of what is already there in the operating system. So if you think of authentication, secure authentication, you probably will start thinking of using some OAuth scheme. Things like Google and Facebook and that sort of providers, they have already those schemes in place, and you can use them from your Xamarin application. Now the thing is, implementing that yourself is actually a lot of work. So what you typically can do is use Xamarin.Auth to fix this. So it's based on OAuth, and what it will do is your application will go out to Google, ask Google to allow the user to authenticate. So the user gets a Google screen or a Facebook login screen. Then user enters his credentials. That gives you an authorization code that can give you access to the token, and then the application stores that token. And from then on, that token is used to do the communication with the backend. And in the backend, it will check if that token is still valid and that sort of thing. Doing all that yourself, like I said, can actually be quite a lot of work. So let's take a look at how we can do this. So this is actually the schema. That's what I'm going to show you next. So let's see how we can actually do this authentication. Which one is this from, by the way? I can't remember. I know. I think it's also Airplane. I think so. That's probably also Airplane. So all right. So so how can we fix this? Now I did try. I think. I have problems connecting the, so I'm now on the wired network, we'll see. So this is a very basic application that's going to try to use Xamarin.Auth to go out to Google, but I think it's the wireless network is not allowing my Google emulator, my Android emulator onto the network. So we'll see. It's pretty slow. So it should open, there we go. So it's now sending it off to the browser, but I see this little cross here. So I'm afraid that this, I don't think it actually has network. So, yeah. Yeah, I am on the cable, but it's apparently not going through. So I'm connected with the cable, but okay. So normally this would show a Google login page. I think you can imagine something with that. And then if I log in, then on my application will get back the information. Let's take a look at the code. I think that's more important. The first thing is I've added this reference to, sorry, you should click here, to Xamarin.Auth. That's what you see there. So Xamarin.Auth is the package that you can install. This is Xamarin Forms. You also have to add Xamarin.Auth in the Droid and in the iOS projects natively as well. So this is now, like I said, in Xamarin Forms, but we can do this natively as well. So what is this going to do? The first thing I need to do is I need to go to Google, console.dev.google.com. So the Google Developer Console, and there you can actually register a new project, and that will give you back an application client ID. That client ID I have here, that is going to be stored inside of the application. That's something I cannot really live without. So even if someone hacks my application, well, I do need that thing to be in there. You could download it from a backend, but again, yeah, it's an extra step that might make the developer's life, the hacker's life a bit more difficult. So actually, sorry, this is the client ID that I'm going to use for my application to authenticate. This is the endpoint I'm going to authenticate with, and this is in the end the endpoint that I'm going to invoke and ask Google for user info, such as the email. So what are we going to do? We are going to, I'm not going to talk about the storage just yet. We're going to do that in the next demo. So when I click on that login button, what I was trying to do, or what was actually happening, was opening that Google login page. Now, how did we do that? Well, we have this OAuth2 authenticator object that we're building up, passing it. So that is part of Xamarin.Auth. That gets in the client ID, gets in where we need to go for the authorization, and also needs to get in or get information about where we are going to go for the authorization token. Then, basically, what we're then going to do, so then because this we cannot really do directly from Xamarin itself, because it will actually need to work with an intent. So we need to do that in the Xamarin Android project rather than in the Xamarin Forms project. So what I'm doing there is to that authentication state object, that's an object that is basically being used to share information from my Xamarin Forms application into my Xamarin Android application. I'm going to give back, let's say, the control to the Xamarin Android application. And I also have registered what needs to be invoked when the authentication happened correctly inside of the Xamarin Android application. So in this line here, we're basically saying, now create that login screen. So hand it off to Google, go ahead, and we'll wait for the response. So this hands off this will actually trigger the opening of the login browser. By the way, if you do this, you could do this also directly inside of a web view, inside of your application. The recommendation is using the external browser, Why? Because if you use it in browser, in-app browser, then you can actually still from your application get access to the username, password information being entered there. So from a privacy perspective for the user, it's better that it goes off to the server, to the browser, and then gives back to your application. It's actually better to do it in the external browser rather than in the in-app browser. So this sends the request off to Google. And in my Android application, I now need to listen for an intent coming back. So basically what I'm going to do here is have this intent, as you can see here, what am I saying? The intent filter that says data schemes, and that is the inverted client ID, which is basically the authorization that Google says, well, I'm going to send that information with the intent, and it's going to be captured by this intent. At that point, my application knows that the external authentication has actually been completed. So we are now going to send basically the control back to the original handling of that authentication scheme. So that will actually send us back to the Xamarin Forms application where this completed authorization event is going to be fired. And that brings us here where we are going to get access to whatever the user did. Did the user authenticate successfully? Yeah, if that is the case, so then E is authenticated, is going to be true. At that point, we are going to try to get information for the user. So we're going to create, so we're now authenticated. At this point, we don't have an authorization, we have basically authorization to start asking Google about information of the user that actually did the registration. And that's what I'm doing there. So I'm going to send a new request to that user info URL. That was one of the constants that I had created. That is going to give me back information, in this case, such as the user email. And that's what I'm going to do here. That's going to come back as JSON. I'm going to deserialize that, and actually I would get access to the user's email at this point. Right? And at this point, I know that the user is authenticated. I have his information, so we're using third-party authentication. One of the things that we now should do, because we at this point have now securely authenticated the user, we also now need to store information about that user. It could be that we want to store a token, maybe a username, that sort of thing. Don't store that in plain text, but make sure that you do that also in a secure way. And again, Xamarin.Auth comes to the rescue. There's a second step, second thing that the library will do, and that is making sure that you can store information in a secure way. Now, if you think of how this is going to be handled, well, this is actually an abstraction layer on top of how the platforms do things. Think back of M1. If we don't use it correctly, well, then it's no use at all, the improper platform usage. Well, that's what this thing is also going to say. iOS has this thing called keychain that allows me to store information securely. Android has key store, and UWP has password vault. Accessing those APIs natively yourself, you can do that from Xamarin. But why bother? Xamarin.Auth does that for you. So they've built basically an abstraction on top of these three platforms. You simply write stuff into Xamarin.Auth, and that will safely store the information for you in the underlying platform's infrastructure. So this is doing it correctly for you. So let's take a look at how we can store information securely. So I'm actually going to switch demos. This demo is also doing it, but I have another one here. Secure storage, which is actually going to show you a bit more about the API that we get with Xamarin.Auth to do storage. So what I have here, again, I have a reference to Xamarin.Auth, of course. So this whole thing evolves around the so-called account store. This is also part of Xamarin.Auth, and I can create new account stores. That's what I'm doing there, account store.create. And in this case, I am going to, maybe not 100% a good practice, but this is just to show you what you can do. So you can actually store, in this case, quite securely the username and password on the device. This goes into iOS keychain and Android, and in WP, it will also use a secure way of doing this. So what I'm going to do is first, in this case, I'm going to check if I already can find that username. So I can actually, through an account store, ask if I can actually get access to a particular, or if I already have stored that information. It's basically key value, what I'm going to do. And I also pass this service ID, as you see here. The service ID is just a name to group things. And you could say that this is the name of my application, really, and it's like an identifier to store everything correctly in these things. Basically, if you have multiple places, if you want to store information from Google coming in, if you want to store information from Facebook coming in, well, use that as the service ID when you store information into the account store. So here I'm going to check if I can, on the account store, already find something. If not, well, then I say, oh, sorry, we cannot find something. And then I'm going to create, if we haven't already created a local account, then I'm going to create a new account. And on that account, which is also part of Xamarin.Auth, I have this properties dictionary to which I can add key value pairs. So that's, in this case, storing the password securely. This is, in my opinion, for that reason, not a good thing, because I would actually recommend, if you need to store the password, perhaps for offline validation, store the hash. Hash it first, maybe a couple of times, and store that. And when you then want to validate that the user has authenticated, store the user's actually filled in password and compare the hashes rather than comparing the password. But that's not what I want to show you here. Here I just want to show you the account store that we are going to use. And that afterwards, I just simply call account store.save, and that will hand it off to the native implementation of the securely storing information on the device. And so we are relying here on the platform, but I think a lot of applications need to do that at some point, and that's what we're doing here. All right, a couple more things. We have a couple of minutes left. Now, you may have heard of this new library called the Xamarin.Essentials, which is basically like a wrapper for the older Xamarin plugins. So the plugins were actually a library of standalone plugins available for Xamarin iOS, Android, and Xamarin Forms. Well, they've grouped this. I think like 25 of the plugins are now part of one package called Xamarin.Essentials. And Xamarin.Essentials also includes something to solve basically insecure data storage. It's a very simple API that also uses underlying platform infrastructure to securely store information on Android, iOS, and also on UWP in this case. So let me show you that briefly. So let's go back to this one. And let's bring that in. And this is an extremely simple API to store things. And you don't have to use it just for username passwords. You simply can store whatever information that you feel that you should be storing securely. We've mentioned it a couple of times. Use that for simply storing all the information that you want to store securely. So this is the, here we are using the API. This is already referencing Xamarin.Essentials as a library. By the way, Xamarin.Essentials is still in beta, so it's not official yet, but you can definitely use it. What am I doing here? No, this is not the one I wanted to use. It's this one. So the API, like I said, is pretty simple. The API is called Secure Storage, and you can get data. That's what I'm doing here. I get asynchronously some data. I check if it's null, then I give back an empty string, so then I know it's not there yet. And to store information, I simply call set async. And again, this will store the information in the underlying infrastructure of the platform in a secure way. So you're definitely 100% sure that this is about as good as it gets to store information securely. That's the Essentials package, a very simple way to actually store stuff. I'm going to skip, so quickly, very briefly, insecure communication. Xamarin has support for TLS 1.2, basically starting from Android 5, and on Xamarin iOS, it hasn't been really a problem. All applications now support TLS 1.2. You can typically use HTTP client or the native APIs as well, so you can basically not make the mistake, let's say, of doing insecure communication. So Xamarin does support TLS in full. So if your backend supports TLS, don't use an older version on the backend either for your certificates, and then you will actually be in a good place because Xamarin does support it. So I didn't have any demos on that. I have some screenshots on what you should be enabling. I want to show you two more small things. And that's this thing called for insecure communication. So the communication part is one thing, but also making sure that you're talking to the correct backend is another. It could be that someone has made it possible to reroute the traffic by perhaps you're not doing certificate checks in your application. And what you should actually do at that point is something called certificate pinning. Now, certificate pinning really talks about you validating the client side, the public part, let's say, of the AP of the server key, or the private. What am I saying? The public part of the certificate. That's what you're going to validate. So you're going to, in your application code, hard code the public part, and when you download, when you talk with the backend, you're going to download the certificate, and you're going to validate if that string in your application's code is identical to the public part of the certificate. And if someone is rerouting your traffic, then of course the certificate will not be the same, and then you can actually validate if that is going to be the correct backend that you're talking with. That's what certificate pinning is really all about. So let me show you that in code. Certificate pinning is this one. So what I'm going to do is, as you see here, I have this called the class called the SSL validator, which I have actually registered in the app XAML to be called, to be initialized together with the application. So very early in the application's functionality, I'm calling this initialize. And I'm using this service point manager class to actually, let's say, hook into every server-side call the validation check of my client certificate. That's what I'm doing here with the server certificate validation callback. So I hard code the public key of my certificate of my own backend. So that's this part, a very long string. You may be thinking, is that not a security risk? Of course not, because it is just the public part of my certificate. Anyone can access that. And so basically, whenever I make a call to the backend, what I'm going to do is I'm going to check simply that the certificate that has been sent back is effectively containing the same public key. And only if that is the case, I allow the call to continue. Now, of course, code tampering could happen and they could replace that. But again, it's going to add an extra layer of security to make sure that no one can start tampering with the communication of your application. And one last thing is, like I already mentioned, this is a bit of a simple, very simple thing to do, but it's a very common thing that happens. If you look at your banking application, I hope that actually as soon as you put the application in the background, you don't see the actual screen anymore. You should actually, as soon as your application contains sensitive information, as soon as it's going to be backgrounded, make sure that you don't allow the operating system to take a screenshot. It will take a screenshot, but don't let it take a screenshot of whatever information is on there. You can actually very easily detect if the application goes into the background and then blur the screen or put some overlay on top of it, so that whenever the operating system does take a screenshot, it will actually take a screenshot of that overlay or the blurred screen. And this is actually pretty simple to do. Let's go back here and let's take a look at, where is this thing? Where's that thing gone to? Data leakage, that's of course this one. Data leakage, that's the one. It's actually pretty simple. It really has not a lot of code to actually be enabled. It works on iOS and Android pretty much the same way. So what we need to do is, let's take a look at Android. So I have this main activity, and this is of course if you do Xamarin Android, it happens not in, sorry, if you do Xamarin Forms, it happens in Xamarin Android, because this cannot be done directly from Xamarin Forms, I think. That's what I'm doing here. As soon as I go into the background, I'm actually going to, this line here at the bottom will actually create an overlay. It's actually very simple in Android. In iOS, you have to do it yourself in the app delegate, in the thing over here. As soon as we do over here, in the on-resign activation, that's basically detecting, hey, we're being backgrounded. What we're going to do is we're going to create an overlay. We're going to blur things here, and we're actually going to put that over the entire screen. Hence, before actually the screenshot is being taken, we have basically overlaid our application with a blur, and then the operating system will take a screenshot of the blur rather than the actual information. So we are 5 minutes over time. I think my time is really up at this point. So I hope I've given you some information on securely making your application work. So don't let this bite you, because it will come back to you in much more painful situations as this one. Thank you for being here. I hope you enjoyed it, and enjoy the rest of the conference. Thank you.